Mr. Minnick here, helping my students with A5, which is part of the College Board PictureLab. That's part of the Computer Science A exam curriculum. So here's the student guide, pages 10 through something or other, where A5 is being assigned. I'll let it up to you to answer these questions. They involve inheritance and interfaces, which we will study elsewhere in our course. But after skimming or reading this set of paragraphs, you're asked to do these 5 hands-on exercises and 6 with the challenge. So I'm going to help you with that part of this exercise. Okay, so my write-up for this particular project, at least as it stands right now in February 2017, is found on my website, and here's what my students are no doubt aiming to accomplish. I also have the lecture notes that they should consult. Right now, this is what the lecture notes look like that match up with PictureLab. And I also have a link to the API that's been provided by Professor Erickson and the College Board folks in case this API is helpful to figure out any of the aspects of this project. Okay, let's begin. I'm assuming that you've already, my students at least, have already set up the PictureLab project in their JGrasp workspace. And I've already browsed to it here. I'm now going to use this menu command to open up the project. The project is found in my workspace. Here's the file that I double-click to open up the project. It's now officially open. I can view each individual file. And our first job is to open up PictureTester and execute its main method. So I'm going to do that, PictureTester, double click. I always compile things first before I execute with this icon, so I'm going to compile it and verify that it says operation complete. No errors were found in this code, which is good because I downloaded it from College Board. And now I'm going to execute PictureTester. Now notice this class, PictureTester, does indeed have a main method. If it didn't have a main method, then I cannot execute it. You could compile it, but you can't execute it. It won't do anything. There's no main method. So there is a main method, and there's only one line of code that's not commented out. This call statement here for the methods test 0 blue. Let's execute it. And this happens. We have 2 beach photos that pop up in 2 separate frames, as they call these. And the original one looks like this, and the other one's kind of a yellowish. Okay, so let's explain that behavior and see why it does that. Well, we only have this one line of code to begin with, so we track down this method test 0 blue. It's a static method that must be found somewhere in this class. Let's scroll up and look for it. Oh, here it is, test 0 blue. So really, these 4 lines of code are executing. We are declaring a picture object named beach. We are instantiating it using some other constructor from the picture class. I'm not going to drill down into that, but just trust that it works. I assume Professor Erickson went on vacation, took a picture of the beach, and that JPEG file, which is included in the images folder that's somewhere in this project, that properly comes up because the explore method from the picture class apparently shows that picture. We don't need to concern ourselves with how that works. That's beyond the scope of the AP exam. So that just pops up that first picture of the beach. Then this line of code executes. So there's a 0 blue method in the picture class that turns all the blue pixels to 0 instead of a number between 0 and 255, they all get zeroed out. And then, because that permanently changes and scars the copy of the beach photo that's in the memory of the computer, we then re-display it, because this Explore method more or less displays and pops up the picture. The second copy of it that's popped up has all the blue like sort of washed out. The first version, it's fine, but after this happens, because that's a modifier method, this copy is a bit different. Okay, so let's step into this a little bit further to see how it's working behind the scenes. And where would you go behind the scenes to see how it does this zero blue stuff? Well, apparently this is a method in the picture class, because beach is a picture reference. So let's come over here and find the picture class. There it is. I'm going to double click it. Right now, remember, I'm in the picture tester class. So double click over here on picture. That brings up this tab. And in this class, there is a zero blue method somewhere. Here it is. So this is the code that's making it happen. That's what's causing the washed out yellowish look, which is setting every blue pixel gets its value set equal to 0. We've already studied how RGB, red, green, blue, can have numbers in each spot there between 0 and 255. Well, that third parameter, red, green, and blue, it's 0. They're all turning to 0. So what's this double nested for loop doing? Well, we're declaring a local variable named pixels. That variable is a two-dimensional array. Instead of ints, it's a two-dimensional array of pixel objects, which we don't need to trace down into and figure out how that works. That's beyond the scope of the AP exam, but it's there in case you want to anyway. You can double click and look at it. So we're declaring an array to the array, and because of inheritance, well, actually not because of inheritance, we are specifying that we want to execute the getPixels2D method from this class. And if we don't find a method called getPixels2D in this class, then we are moving up one level to the parent class, which right now we don't need to concern ourselves with. How the picture class extends its parent class, which I read earlier is simple picture. Just suffice to say that all the little teeny tiny pixels in that beautiful beach picture are stored in a two-dimensional array, and the top left corner pixel is in position 0, 0, and the bottom right corner position is something like 640 or 639 or 480 or something like that. So we studied that elsewhere. And then because of this double nested for loop, even though this is a for each loop or enhanced for loop, if you will, we are stepping through each row of pixels, each horizontal row of pixels, and then within each horizontal row of pixels, we are going pixel by pixel by pixel across the columns, and each pixel in its own turn gets plugged into this variable named pixel obj, and that variable is having its blueness changed to 0. And we don't really need to concern ourselves how the setBlue method works, but apparently there's a setBlue method in the pixel class over here, but it's turning it to blue. So because nothing's returned, this is a void method. We bubble back up or back over to picture tester class where we called that method 0blue. And this method, if you remember, was being called by the main method down here. And because it doesn't return anything, it's void. Nothing gets returned or system out printed or anything like that. This is just a call statement that just plain works because of what I just traced through. Let's execute it one more time. two picture frames pop up with two copies of the picture. And this is the original one with a nice blue color to that sky. But when you take all the blue out, this is kind of the red-greenish look that you have. Maybe you're wearing fancy sunglasses that take out blue from the spectrum of colors that reaches your retina. Okay, so closing that exercise up, we just finished working together here, exercise 1. Now, the author here wants you to uncomment out other lines of code in the main method to test other methods that are over in the picture class. So we're basically playing with the picture tester class to test methods that are in the picture class. So here we go. Let's do exercise 2 here. Well, I'm kind of finished testing zero blue. I know it works, so I'm going to comment that call statement out. And I'm just going to scroll up here and see that there's apparently a method called test edge detection. I have no idea what it does. I could always go to the API and figure out what test edge, read what it does, but that's no fun. Let's actually run the code and see what happens with experience. So test edge detection is a method that's being tested right here. I'm going to take out those two forward slashes. And what the heck, let's compile it and see what happens. Operation complete. Awesome. Let's execute it. Okay, I'm testing the method test edge detection, and this is what it does. That's interesting. Oh well. If you're really curious as to how it works, well, let's trace it. You would come here to this method. It's a swan picture, supposedly. We go to the picture class and look for a method called edge detection. Here's my picture class. There's a method called edge detection somewhere in here. Here it is. And whatever that does, that's what's happening. I'm not going to step through this. It does make use of pixel objects and a two-dimensional array of, well, this is the set of pixels that make up the swan JPEG. It's setting things equal to null because it would not make sense to set that equal to 0. It's not an int. Left pixel is a pixel, so you set it equal to null for good safe style. Double nested for loop, and instead of an enhanced for loop, we're stepping through this with a good old-fashioned traditional for loop that does row plus plus and column minus plus plus rather, and whatever happens here happens. You can trace that on your own, but at least we tested it to see if it works. Okay, back over to my picture tester. Let's test another interesting method here, like test collage. I can take away the two little forward slashes there and execute that. It automatically compiles in JGrasp. And here is what collage does. Okay, that's nice. You can trace it on your own as much as you want. And there are a few other tester methods here, like test mirror temple, test mirror vertical, and we've already tested zero blue. So mirror, these two, have fun testing these on your own just to be curious and see what they do. Why am I not seeing them here? Here they are. These two right here can be tested. They also come up, I think, in later exercises in the PictureLab. Now, do not test keep only blue, because it doesn't have, that method does not exist up here yet. You're going to be making that shortly. So some of these cannot be tested or uncommented out. Okay, we just finished together, you and I. We just finished some of exercise 2. You can test a couple of those other ones, methods that were available. Okay, please read this on your own time there, and now, and make note of this code segment. Now we're ready to move on to exercise 3. This is where it starts to get hard. You have to write the method named keep only blue. So instead of changing things to 0, you're changing green and red to 0, but you're keeping the blue color. Oh, okay, you're kind of doing the flip-flop, the opposite of what we saw in the previous example. So to do this, we create a class method to test this over in Picture Tester. Let's do that first. In Picture Tester, we need to create a test method. So I'm just going to copy and paste test0blue, highlight, copy, and I'm just going to slap it in right here, making room, nice neat style. Paste this in here. Instead of naming it test0blue, test keep only blue. Makes sense. And I'll just change this here to be consistent. The purpose of this method is to test keep only blue. So the test method has this test prefix in front of the name, just like here, 0 blue, get it? Okay, we still want to use the picture of the beach, that's fine. I don't want to use that swan JPEG, let's just keep the beach. Yeah, let's show the original copy of the beach. Then let's call the method that we need to go and write as part of this assignment. So the name of the method is going to be keep only blue. I keep this there so that it shows me what it looks like after this executes. So where the heck do I go to implement this method? Well, because beach is a picture object or picture reference, I have to go to the picture class, which I have up already in this other tab here in JGrasp. Now this is finished. This editing work, oh no, I didn't uncomment this out. This line of code here, test keep only blue, now needs to be brought into play so that this line of code in the main method of the tester class calls this method that we just copied and pasted and edited, which in turn calls the method keep only blue that's going to be over here. So while we're here, let's compile this. And don't freak out, but we have an error message. We should have an error message. Let's compile this again. Yep, we have an error message because it's squawking and saying, hey, there is no method keep only blue over in the picture class. So that's because we haven't written or implemented that method keep only blue yet. So, but at least we're ready to go with our tester class here. So let's now slide over to the picture class. And where do you start with something like this? Well, let's just make room for something here. And let's just kind of copy and paste 0 blue and make room right below it for keep only blue. Oops, paste. Okay, clean this up a little bit here spacing wise. So I think I just did it right. No, I didn't paste correctly. Sorry about that. Right here, I want to paste. Okay, I never copied correctly. So highlight, copy, click, paste. There. Okay. This copy is going to be called keep only blue. It's going to be a void method, and it's got to be public. Method to, instead of set the blue to 0, set the red and the green hues, or whatever you want to call it, colors to 0. Okay, that's what the purpose of this is, essentially keeping the blue and wiping everything else out to 0. Okay, this line of code is good because that sort of gets all the pixels in that complicated picture into a nice giant two-dimensional array. I'll use my double-nested enhanced for loop. This is fine, this is fine, so guess what? Instead of setting blue to 0, let's just wing it and guess that there's a set red method. Now you can be the kind of rebel that just kind of, or the dangerous guy, just kind of tries things like this. Pixel obj object set red and green to 0. This might do it. We don't want to set the blue to 0. No, we want to keep it whatever its original number between 0 and 255 is. But is there a set red method in the pixel class? Well, there was a set blue method, so it would be logical that there's a set red method. But how can you tell for sure? Well, you could go visit the pixel class. If you scroll up and down in this pixel class, oh, there's a get red, so there's probably a set red. And the setters are probably right below the getters. And don't ask me how set red works, but it just works. I don't have time to trace, nor the interest, to trace the correct value method and the update picture methods that are also in this class, or the get green, or the get blue, or the get alpha for that matter. Just trust that they work. Like when you turn the key to a car when you get your driver's license, you just trust that it will start and drive away. Okay, so I'm done kind of messing around in the Java class. I'm going to close that so I don't get confused. And I'm back to where all the action is. Now it's time to compile this to make sure there are no missing semicolons. Compile. And it's fine. Let me clear that out and just make sure it's compiling fine. Operation complete. Yep. Now don't execute. Because if you execute with this file open right now in your window here, it's going to execute the main method that's in this picture class, which is not the main method that we want. This is currently hooked up to execute 0blue. We want it to have this file active, picture tester, and with that file active here, its main method executes, which is the one right now that has this call statement, test keep only blue, which, as I repeat, will call this method, which is testing keep only blue, which is what we just got finished writing out, or in other words, implementing over here in the picture class. Rewatch this video in slow motion if I just confused the heck out of you. But anyway, with picture test brought forward here in active, I'm going to compile it just to make sure it didn't have any compile errors in this changing. And now let's execute it, and we should see the result of our work. We should keep only blue. This is original, familiar looking picture, and look, all the red and green was taken out. Now that's cool. And it's all code. Just like CGI effects in Hollywood movies. It's all the code. It's all the special effects. No stunt double was required. We just changed the pixels to make it look like the zombie's head was like cut off. It just is all fake pixel editing. Okay, that is a wrap there on exercise 3. And now it's your job to write the negate method and the grayscale method. And depending on the mood that your teacher is in, I may or may not have told you for homework to do the challenging fix underwater method. So good luck with all this. You have to read these directions here and these directions. And it's pretty much similar to what we just did with keep only blue, which remember we modeled on 0blue. Here I think you're taking 250, instead of just like 0 or something, you have to take 255 minus the get green. Because there's a getter, and you can do a get green just like you can do a set blue, or a set green. So use your API, you skim other code that you see available, and good luck. But testing it is pretty much the same actions as I was doing to test keep only blue. Grayscale, to give you a little bit of a hint, it looks like you need to do get red, get green, get blue, add all 3 of those integer values up, divide by 3, and you're basically washing out the colorful picture and making it just a boring set of gray, pale gray pixels. You're dividing that by 3, and then you're using the setters, the set red, set green, and set blue, to set them equal to that new average. So you're using some getters to get the current red, and then a setter to set the red, and dividing by 3. And the challenge, I'll let that totally up to you. One other point. In this project, I was using a double nested enhanced for each loops. But you could, especially if you're old school like me, you could, let's just come up here to keep only blue. No, I'm sorry, to go over to the actual, not test keep only blue, I'm sorry, keep only blue. Let's go to the picture class. I could have done this operation here with double nested traditional for loop. So I'm going to do that quickly just to show you how it works. Just as well as using this double nested enhanced for loop, you could have performed the algorithm like this. You would still want to get the pixels into a two-dimensional array. So that's still in play. But instead of this mess or version, you could always create a pixel object such as pixel obj and set it equal to null at first, because it just makes sense to do that. And then you have your traditional for loops for row equals 0, row less than something, row plus plus, and then of course a good set of curly braces and indentation, and then you go through the columns. Perhaps like this. Column goes up to some point, I'll figure it out later. And then of course all the action will occur in here, and then we close off our loops. So we have a double nested for loop that's going to be used to do the same thing that we did here. Well, with these kinds of traditional for loops, unlike the way an enhanced for loop works, you need to know what the upper boundary is. Well, when you have a two-dimensional array and you're going row by row, it's really just the length of the array. So pixels dot length with no parentheses, because it's an array, not a string. And on the inside, the number of columns is really usually the number of elements that's in the first row, or that's in the first element position of your pixels one-dimensional array. So it would look like this. Okay, so I've got my double nested traditional for loop set up, but I got to do something here. So I basically want to do what I'm doing there. I want to do it here. Well, it's a little bit harder than that. Well, not really, but let's see here. I got to think about this. Let's see. This variable pixel object here or any variable name that you want would be set equal to the current pixel element that you're up to based on the iteration of your row by row, column by column, top down traversal of the two-dimensional array. So each pixel ends up being plugged in here, and one at a time. And then of course with that pixel you want to call its setRed method and set the red's value, alpha value channel equal to 0, and you want to do the same thing with green. So a little bit messier here in the center of this, yet instead of 2 lines of code you have 3 lines of code, that's all. But this should work, and let's compile it. Now we don't want to do this and this all over again, so I'm going to comment this out for now because that I know worked. But I just want to show you how, if you're a person that likes traditional for loops and you don't like the enhanced for loops as much, this should work. I'm going to compile it and see if we have operation complete here. Yes, we do. Don't forget, we're in the picture class. We don't want to run the main method that's in here. That does the 0 blue and not the keep only blue. So I have to move over to picture tester, and now I'm going to test this second version of keep only blue. By compiling and executing this one, I should see a second version of this beach that's very blue, And yes, I do. There's the original, and there's the blue. So that worked with a different type of for loop over there in the picture class as a possible answer to this exercise that would be perfectly acceptable, if I can find it again here. This would be perfectly acceptable if you're just that kind of person that likes traditional for loops. You do have to set pixel object equal to null. Now I'm curious here. If you forgot to set it equal to null, will this compile? Yeah, by default, objects are set equal to null by Java, but you should explicitly set it equal to null just to be safe. It's kind of like setting something, an integer, equal to 0. It's just safe and sometimes required in certain situations. Okay, that's it. I hope give you the best of luck in finishing the rest of these exercises.